Image processing is a set of computational techniques for analyzing, enhancing, compressing, and reconstructing images to improve its quality or to extract useful information. Let's discuss some basic image processing operations. Image resizing is the process of changing the dimensions of an image by scaling it up or down, using techniques like interpolation to preserve quality. In decreasing size, image size is changed by downsampling, which reduces the number of pixels through techniques like interpolation, averaging, or pixel discarding. Increasing size is the opposite case. Size is increased by certain amount, mostly using interpolation. When we increase the size, let's say change from 2 by 2 to 4 by 4 image, we have to make 16 pixels for 4 by 4 image using 4 pixels of 2 by 2 image. We interpolate the remaining pixels. There are different interpolation techniques. Each technique has its pros and cons. Let's discuss them one by one. The nearest neighbor algorithm is the simplest form of interpolation. It selects the value of the closest pixel to the computed pixel location without considering any other neighboring pixels. When resizing an image, for example, the algorithm picks the value of the pixel that is closest to the calculated new pixel location in the original image. No averaging or smoothing is applied. It is fast and computationally inexpensive but produces blocky or pixelated images. Especially when enlarging images, no smoothing occurs, so the result may look jagged or harsh. Often used when speed is more important than visual quality, e.g., real-time processing, low-resource devices. Bilinear interpolation uses the values of the 4 nearest pixels in a 2 by 2 grid to compute the new pixel value. It performs a linear interpolation first in one direction, x or y, and then in the perpendicular direction. A wrought idea of the technique is shown in figure. For each new pixel, bilinear interpolation computes a weighted average of the 4 nearest pixel values. This helps to smooth the transition between pixels. Results in smoother images compared to nearest neighbor, less blocky and more visually appealing. Slight blurring may occur because of the averaging process. While better than nearest neighbor, it might still introduce some artifacts at edges. Common in applications where smooth scaling is necessary without needing high computational resources, e.g., standard image resizing. Bicubic interpolation uses the values of the 16 nearest pixels in a 4 by 4 grid to calculate the new pixel value. It performs cubic interpolation, which is more complex and takes into account more neighboring pixels than bilinear. The algorithm considers the intensity values of 16 surrounding pixels and applies cubic polynomials to perform a weighted average. The result is much smoother than bilinear interpolation. Produces smoother, sharper images with fewer artifacts than both nearest neighbor and bilinear interpolation. Better at preserving fine details and edges, but slower to compute due to the complexity of the algorithm. Small ringing artifacts, halos, might appear around sharp edges. Best used when high-quality scaling or transformations are required, such as in photo editing, medical imaging, or printing. Comparison is illustrated in the figure. Image cropping is the process of selecting and cutting out a rectangular portion of an image to focus on a specific area, while discarding the rest.